been working with algebra, but more equations. So just building on what we've done with expressions. And it says, what is the solution to the equation below? Now, there's a formal way of how to solve this by undoing all the operations. We're going to have full-on lessons with that down the road. Right now, we can just kind of think about 5 times what number plus 9 is 19. Now, again, all of us are coming from different places. Some of you see this, you know exactly what to do. Some of us might say, hey, I've seen this before, but I really struggle with it. And some of you might even say, I've never seen this. So just kind of like an introductory way to think about equations. I've used what's called the cover-up method, where I say, I cover the whole variable, so the whole thing that has the x, so the 5x, and I ask myself, what does that need to equal? So in other words, I'm thinking about, what am I hiding plus 9 equals 19? So that number, 10 plus 9 is 19. So I need what I'm hiding to equal 10, right? Because 10 plus 9 is 19. So I'm hiding 5x, telling me that we need 5x to equal 10. If 5x is 10, 10 plus 9 is 19. And now, since I have 5 times x, I'm thinking 5 times what is 10? That would be 2. So x needs to be 2. Now again, our lesson today is not about solving. We will have a lot of lessons on solving. That's such a fundamental piece of algebra. Today, our lesson is actually more about checking the work. So after we get a value that we think is an answer, how do we know if that's correct? Well, what we'll do is we'll take the value of x and we'll substitute it into the equation for that x that's already in there. Now, we've done this part, but only with expressions. So the only difference now is we have that equal sign in there. I'm still going to replace it, the x with 2, and use parentheses. And now I'm going to work with the left side and see if we can't get this to be equal. So 5 times 2 is 10. 10 plus 9 is 19, and 19 does equal 19. That is a true statement. And that confirms that 2 is in fact the solution. This is what we're focusing on today. So when we plug a number into an equation, is that a solution or not? Okay. So just a few definitions. We've talked about expressions in here. Expressions and equations, a lot of students will use those words interchangeably, but they are different. Equations have the equal sign. Expressions do not have an equal sign. Okay, so an equation is a mathematical sentence that has the equal sign. We'll also talk about inequalities, which is also a math sentence, but now those use the less than, or equal to, or greater than or equal to signs. A solution to an equation or an inequality is a value for a variable that makes the statement true. Okay, meaning we need to end with something that is mathematically correct. Okay, well, let's jump into, we don't have a ton of examples. It's going to be a short day. It's a great day to do binder checks and some of these other things. No homework because you'll probably be able to finish in class. It's kind of nice that this lesson falls on this day. All right, so determine if the given value is a solution. X equals 3. Remember that we're going to replace the 3 in the equation, or the x in the equation, with 3. So this is 9 times 3 plus 8, and we're checking, does that equal 35? 9 times 3 is 27. 27 plus 8 is 35. Notice the work here. For those of you in here that aren't showing work, because you're like, this is easy, I can do it in my head. Today is your day to practice showing work. Okay, as easy as it might be. So when I check work, or when I check your homework, I want to see everything written out. This is a skill and one that we need to practice. Even if all the operations getting you there are really easy and you feel like you can do it in your head. So 35 equals 35. That is a true statement. So we would say yes. X equals 3 is in fact a solution. All right, why don't you all do 2, 3, and 4? And we'll check them. Shh. as you're checking your work here, not only are we going to pay attention to if the given if the given value is a solution, but also we want to make sure we're getting the correct numbers at the end so that all the algebra leading you there is correct. This is exactly like a big part of what your quiz was on. Order of operations. Yeah, it's on a smaller level, but this is still order of operations work. So we still want to make sure that in 2 you're ending with negative 21. Does it equal 3? Clearly it does not. Right? And that's when something is not equal, we put a dash through the equal sign like that. So if they're not equal and gives us a false statement, that tells us that the given value is not a solution. So for 2, it is not a solution. For 3, it is also not a solution. I don't know why I put an X there. Negative 9 does not equal 5. And then on 4, I end with negative 10 equaling negative 10, which that is in fact true. All right, everyone, math checks out here. Did I make mistakes? Because it's going to happen. When it happens, I hope we catch it and tell me. All right, let's flip this over. The last 2 slides are just different types of equations or inequalities. So the next one we're going to work through includes absolute value. And just like before, I'll do one for you, and then I'll have y'all do the next one. So we're checking, is this equation 2 for when n equals negative 7. So in our equation, everything stays the same, except the absolute value of n is now negative 7, and that equals negative 9. Now, one thing that having taught this class before, I think a lot of students don't feel like they need to study math. They think just doing math takes care of that, which is true for the most part. But I know that by checking or grading your quizzes and working with some of you, this is something we forget, okay, what these lines are. What is the name of this, though? Somebody help me real quick. Anissa, go ahead. Absolute value. If you did not think absolute value when I asked that question, go home today and take 5 minutes to look back through your notes, study what the absolute value brackets look like, and commit some time to actually studying it. And in addition to that, commit some time to what it means to take the absolute value of a number. Again, these are in your notes. So the whole point of that is be willing to commit some time to studying math notes. That's how we remember these things and aren't like, oh yeah, I used to know it, but I forgot. We have to commit some time to actually studying these things. So when we take the absolute value of a number, that just means to make it positive, not change the sign, but just simply make it positive. Once we make it positive, I change the absolute value brackets to regular parentheses, which shows that I've taken the absolute value of it. And now, negative 2 minus 7, that is negative 9. So I get negative 9 equals negative 9. That is true, and thus it is a solution. All right, just like before, I'm going to have you all do 6, 7, and 8. We'll get some of you to come up to the boards for 10, 11, and 12. Okay, but a few minutes to do 6, 7, and 8. Here's what the word, how should go? With 6, I end with 49 is not equal to 59. So 6 is no. Again, if you're not getting 49 on the left side, figure out why. Okay, ask somebody in your group, where is the mistake happening? Yes, getting to know is good, but we want to make sure we get there for the right reasons, not by making a mistake and getting lucky. Okay, we want to make sure that we're actually getting this process down. So 49 does not equal 59. For 7, the left side, I end up getting negative 104. After subbing in 11, negative 104 does not equal negative 94. Side again is no. And then on 8, I end with negative 15 equals negative 15, which is a true statement. And thus, negative 6 is a solution. And then just be careful that when you take the absolute value of a number, and we're always making it positive, not changing the sign, but making it positive. All right. Last 4. And now we're dealing with inequalities. These are going to be problems, and I'm going to really encourage you to read them out loud once we get to the end, okay? Because knowing these symbols, the less than, the greater than or equal to, are really important and show up a lot in this class. So I'm going to do 9. I'm going to come around and assign your group a problem to go and show your work up on the board like we've done before. And then we'll start homework time after that. I'm going to also get some of you taking the quiz and whatnot. So we got lots of stuff done here. Okay. First, I'm going to replace the 5 or the x with 5. So to start, it's all the same. In fact, for the most part, it's all the same. The only thing that's different is what we're checking at the end. 5 plus 9 is 14. And then 5 times 14 is 70. Now, when you get here, don't be afraid to say this out loud, okay? The inequality symbol, this is the less than sign. And again, if we don't know these, come tell me and I'll write them down. That way we can have an idea as to which one's which. But this is 70 is less than 85. Is that true or false that 70 is less than 85? That's very true. Since that's a true statement, that means that 5 is a number or a solution to the inequality. And in fact, with inequalities, there are lots of numbers that make them true most of the time. All right, so I'm going to have you all do 10, 11, and 12. All right, all the work I see on the board is perfect. I do see one mistake with this one right here. I'll talk about that in a second. But we conclude that for all of these, the answer is yes. Every answer provided makes the inequality true. And that's going to be a common thing with inequalities, where a lot of values make those inequalities true. Okay, and we'll see more of that when we actually dive into solving inequalities down the road. So it looks like, I think with whoever over here got negative 34 is greater than 40. I just don't think we multiplied negative 6 and 7 correctly. Which happens. Okay, it happens. I mess that up all the time too. But one thing that I really like on the board is all the work that's being shown. Okay, I cannot emphasize that enough. Keep showing work. Keep showing work. This is one that a lot of people would probably mess up. Negative 34 is greater than negative 40. Remember with negative numbers, that is in fact true. Okay, negative 40 is smaller or more negative than negative 34. Okay, before we start homework time, I know there's one thing on the homework that 5 and 6 need some fixing. Stop the video.